Astronomers turned the world's most powerful space telescope toward an icy world nearly 5 billion kilometers from Earth. And what they found didn't make sense. Pluto, once dismissed as a frozen and lifeless object, famously reclassified, a world many people had assumed was cold, inactive, and finished, is may conceal liquid water far below its frozen exterior. It also shows enormous structures that scientists interpret as cryovolcanoes. Its atmosphere is being controlled by something nobody predicted. And the James Webb Space Telescope just confirmed that the rules we thought governed this part of the solar system are completely wrong. That is far more than a minor surprise. This is the kind of discovery that makes planetary scientists stop mid-sentence and go quiet. Stay with me because by the end of this video, you're going to look at that tiny dot in the night sky very, very differently. For most of the 20th century, Pluto remained little more than a faint point of light. Clyde Tombaugh discovered it in 1930. Not because he saw anything impressive, but because he noticed a faint dot that moved slightly against the background stars over several nights. That was it. That was Pluto's grand introduction to humanity. A dot, a shift, a question mark. And for most of the next century, that's almost exactly what it stayed. 1 minute, 1 second. Even the Hubble Space Telescope, one of the most sophisticated instruments humanity had ever launched into space, could only produce blurry, smudged images of Pluto. A few patches of light, a few patches of dark, no detail, no clarity, just a mottled blob floating in the outer darkness of the solar system. So scientists did what scientists do when they don't have data. They made assumptions. And the assumptions made sense, honestly. Think about where Pluto is. It orbits the Sun at an average distance of about 5.9 billion kilometers. The sunlight that reaches it is roughly 1,600 times weaker than what we receive here on Earth. At that distance, in that cold, temperatures on Pluto's surface hover around -230 degrees Celsius. A small rocky icy world should have radiated away all its internal heat of formation within a few 100 million years. Maybe a billion if you were being generous. The logic was airtight. Without a large parent planet nearby to flex and squeeze its interior the way Jupiter squeezes Europa, without enough radioactive 2 minutes, 1 second material in its core to generate meaningful heat through decay, Pluto had no energy source. No energy source means no geological activity. No geological activity means a dead world, frozen, cratered, finished, a relic sitting quietly in the cosmic cold, unchanged for billions of years. The old picture of Pluto was not based on neglect, it followed from what scientists believed the physics demanded. The math said it should be dead. So dead it was. Everything changed once a spacecraft finally reached Pluto. The New Horizons spacecraft was about the size of a grand piano. Not exactly an imposing machine for one of the most ambitious missions in the history of space exploration. But it launched in January 2006. And for the next 9.5 years, it crossed the entire solar system, threading between planets, getting a gravitational boost from Jupiter and hurtling deeper and deeper into the outer dark. On July 14, 2015, New Horizons arrived at Pluto. It didn't slow down. It couldn't. It had no way to brake enough to enter orbit, and the fuel weight would have made the mission impossible. So instead, it did something remarkable. It screamed past the surface at roughly 50,000 kilometers per hour. Closer than London is to Sydney in terms of altitude, with only one chance to photograph everything. One pass, one **** window, no second attempts. Then it turned its antenna toward Earth and started transmitting. Even at the speed of light, the signal took 4.5 *** hours to arrive. And when it did, the data trickled in at an almost painfully slow rate, roughly 1 kilobit per second, slower than a 1990s dial-up modem. Downloading the complete set of images and data from that single afternoon took 16 months. 16 months to process one **** flyby, one afternoon at Pluto. When the complete resolution images finally arrived, when scientists saw what was actually out there, they had to rewrite the textbooks. Pluto wasn't a dead cratered ball. It had mountains, not small ones, ranges of peaks rising as high as the Rocky Mountains, some of them 3,000 to 4,000 m** tall. And these mountains weren't made of rock. They were made of water ice frozen so hard in that extreme cold that it behaves structurally exactly like *** stone. Water ice mountains standing tall on a nitrogen ice plain. That result had not been expected. There were vast smooth plains of nitrogen ice, blindingly *** bright, stretching for hundreds of kilometers without a single crater to break them up. There was a blue haze, layers of it hanging more than 100 kilometers. Knife-edged ridges rising hundreds of meters tall formed from methane ice sculpted into blades by a process called sublimation. The same mechanism that *** creates small spiky snow formations called penitentes in the high Andes. But here on Pluto, at a scale roughly 100 ** times larger. But the most significant discovery wasn't what was there. It was what wasn't there. Craters. On an ancient world, you expect a surface covered in impact scars. Billions of years of meteorites and space debris leaving their marks like bullet holes in metal. The entire inner solar system is covered in craters. Our ** moon is covered in craters. Mars is covered in craters. Old dead surfaces collect craters the way old buildings collect cracks. Across huge stretches of Pluto's surface, especially across those bright nitrogen plains, the craters were almost completely absent, smooth, clean, ***, freshly resurfaced. Geologically speaking, something had been actively wiping the slate clean. Something had been repaving the surface and erasing ***, the impact record. A truly inactive world should not be continually renewing its surface like this. Perhaps the most recognizable image returned by New Horizons, the one that appeared on the front page of newspapers around the ** world, showed a massive pale region on Pluto's surface shaped roughly like a heart. It sits just off the equator, and ***, it's enormous, about 1,600 kilometers across, wide enough to swallow most of the western United States. Scientists named ***, the western half Sputnik Planitia. And it is, in the most literal sense, a wound that healed. Beneath that bright icy surface sits a basin, a depression about 1,000 kilometers wide and roughly 2.5 kilometers deep, almost certainly the scar of an ***, ancient catastrophic impact. An asteroid or comet that slammed into Pluto early in the solar system's history and carved out a massive hole. Over billions of years, nitrogen ice has slowly flooded that basin until it became the largest known glacier in the entire solar system. But that ice isn't just sitting ** still. When New Horizons photographed Sputnik Planitia up close, it showed something astonishing. The surface of the glacier is broken into a honeycomb *** pattern. Irregular polygons, each 1/10 of a kilometer across, tiling the surface like a massive mosaic. The *** explanation is convection. The same slow churning process that drives Earth's mantle. Warmer ice deep in the glacier rises toward the center of each polygon ***, spreads outward, cools, and sinks back down at the edges. The same lazy circular motion you'd see in a lava lamp. Except here it plays out across a *** plane the size of Texas over timescales of millions of years. This is active geology on a world that was supposed to be dead. There is another *** positioning problem. And this is where things get genuinely strange. Sputnik Planitia doesn't sit just anywhere on ** Pluto's surface. It sits almost exactly on the line that connects Pluto to its large moon Charon, the tidal axis, the direction in which Charon's gravity pulls ** hardest on Pluto. That alignment is too precise to be coincidence. In 2016, two independent research teams proposed the ** same explanation. The basin actually reoriented Pluto's entire body to land in that position. A process called true polar wander. The basic mechanism is straightforward. A ** sufficiently heavy or buoyant feature on a rotating body will migrate toward the equator along the tidal axis. The axis of gravitational influence from a nearby ** companion. The basin with whatever is beneath it was heavy or buoyant enough to drag the entire crust of Pluto around until it settled into alignment with ** Charon. An entire world rotating within its own skin to rebalance itself. But the math revealed a problem with this explanation. Clear's throat. A deep basin should represent missing mass, a hole where material used to be. Missing ** mass is light, and a light feature doesn't drive polar wander. It resists it. For the numbers to work, something dense and buoyant must be pushing upward ** beneath the basin floor, supplying the hidden mass that makes reorientation possible. The most natural candidate is liquid water, a subsurface ocean ** pressing upward beneath the thin crust of Sputnik Planitia, adding the hidden weight the physics requires. Nobody has seen this ocean directly, but the ** inference has gotten sharper and sharper with every new study. In May 2024, detailed modeling of the cracks and * surface deformations around Sputnik Planitia concluded that if an ocean exists, it's probably somewhat saltier and denser than Earth's seawater, briny.